Good day everyone, here's our math challenge for today. Now let's start with a quarter circle. From here, let's draw a circle inside of this quarter circle. Now our goal is to find the area of this blue region. Given that the length of this quarter circle must be equal to 2 centimeters. Now if you want to try this problem, just pause this video right now, and if you're ready, here's the solution. And I hope you pause this video. Now let's see if you got the correct answer. Now to answer this question, what we're going to do is to focus how do we get this shaded region. To do that, let's focus on the quarter circle. Next, let's draw a circle inside of it. Next, let's draw a square like this. And take note that these blue regions are congruent. Therefore, this is just the same thing. Now, as you can see, to find the area of this blue region, what we're going to do is to take the area of this quarter circle and then subtract the area of this shape, which is 3/4 of a circle, and subtract the area of the, and don't forget to divide this by 2. So this is the area of this shaded region. Now, in order to find the area of this 3-piece, we need the radius of this circle. Now, to find the radius of this circle, what we're going to do is to use this concept. If we have two internally tangent circles, and we draw a tangent line directly to the point of tangency, the point of tangency and the centers of these two circles are said to be collinear. Now this is not hard to prove because we know that the radius of the circle is perpendicular to the tangent line. It directly follows that the point of tangency and the centers of these two circles are collinear. We will use this concept to find the length of the radius of this circle. Now let's consider the point of tangency, the center of this circle, and the center of this quarter circle. Next, from here, let's connect them in a straight line because we know they are collinear. Next, let's draw the radius of this circle like this. Now let R be the radius of this circle. It follows that the length of this segment must be equal to R also, because this is just the radius of this circle. Now also take note that this part is a square. Now since we know the length of the side of this square, therefore we can easily find the length of the diagonal of the square, because the length of the diagonal of the square is equal to the length of the side multiplied by the square root of 2. Now also take note that this segment connecting the point of tangency, the center of this circle, and the center of this quarter circle is equal to the length of the radius of this quarter circle. Therefore, if we add r plus r squared of 2, this will give us 2, or the length of the radius of this quarter circle. Now at this point, let's solve for the value of r. To do that, let's factor out r. So we have r multiplied by 1 plus square root of 2 equals 2. Next, divide both sides by 1 plus square root of 2. Next, rationalize the denominator by multiplying to its conjugate, which is 1 minus square root of 2. Now multiply, the numerator becomes 2 multiplied by 1 minus square root of 2, and the denominator becomes 1 squared minus square root of 2 squared, or simply 1 minus 2. And 1 minus 2 will give us negative 1. Now 2 multiplied by 1 minus square root of 2 divided by negative 1 will give us 2 multiplied by square root of 2 minus 1. Therefore, we now know that the length of the radius of this circle must be equal to 2 multiplied by the square root of 2 minus 1. And also take note that this is also the length of the side of this square. Now we are ready to find the area of this shaded region. Let's focus on the area of this quarter circle. So the area of this quarter circle must be equal to 1/4 pi r squared. Now we use the length of the radius, which is equal to 2. So let's substitute r with 2. So we get 1/4 times pi times 2 squared. Now 2 squared will give us 4. 1/4 multiplied by 4 will give us 1. Therefore, the area of this quarter circle must be equal to pi. Next, let's focus on this figure, which is 3/4 of a circle. So the area of this shape must be equal to 3/4 times pi r squared. Now at this point, we will use the length of the radius of the circle, which is equal to 2 multiplied by the square root of 2 minus 1. Now let's square 2 multiplied by square root of 2 minus 1. If we do that, we get 4 multiplied by 3 minus 2 square root of 2. Now 3/4 times 4 will give us 3. Therefore, the area of this shape must be equal to 3 pi multiplied by 3 minus 2 square root of 2. We're almost done. At this point, let's focus on the area of the square. This is very easy because the area of the square is equal to s squared, wherein the length of the side of the square must be equal to 2 multiplied by square root of 2 minus 1. Now let's square 2 multiplied by square root of 2 minus 1. If we do that, we get 4 multiplied by 3 minus 2 square root of 2. Therefore, the area of the shaded region must be equal to pi minus 3 pi multiplied by 3 minus 2 square root of 2 minus 4 times 3 minus 2 square root of 2 all over 2 square centimeters, or approximately 0.4191 square centimeters. And as always, we're done.